Good morning, students. In the maxima and minima in the section, let z is equal to f of xy. Here the function z containing two independent variables. Here you have to locate the extrema of the function, maxima, minima, or saddle points. For that, we have a working rule. The first point is, first we partially differentiating the function with respect to x, that is f of x. Then partially differentiating with respect to y, then fy. Then second point, fx is equal to 0, fy equal to 0. Fx is equal to 0 and fy equal to 0. Then solving this, we get critical points. X0, Y0, X1, Y1, X2, Y2, etc. Critical points. Then third point, calculate fxx, second derivative. We partially differentiating fx again with respect to x, then we get fxx. Then fyy, we again differentiate fy with respect to y, then we get fyy, second order partial derivative. Then fxy, we partially differentiate with respect to fx with respect to y. So calculate fxx, fyy, fxy. Then substituting the critical point in this, then we get fxx, x0, y0. X0, y0 is a critical point. Then fx, x0, y0. Fyy, x0, y0. Fxy, x0, y0. Then the fourth point is calculate d. To calculate the d, we have a formula. That formula is fxx, fyy minus fxy the whole square. Fx, x0, x0, y0. Fxy, x0, y0. X0, y0. First we find fxx, then substituting that the critical point. Then we get fx, x0, y0. Similarly, fyy, x0, y0. Fxy, whole square, x0, y0. Then the value of d is less than 0. When we calculate the d, when the value d less than 0, less than 0, we say that x0, y0, the critical point is saddle point. D greater than 0. When we take d, when we calculate d, if d greater than 0, we take two cases, case 1 and case 2. Case 1, fxx, x0, y0 greater than 0, fxx, x0, y0 less than 0. When d greater than 0 and fxx, x0, y0 greater than 0, the critical point is relative minima. D greater than 0 and fx, x0, y0 less than 0, the critical point is relative maximum. The last case 7, d equal to 0, no conclusion. This is the procedure for determining extrema of a function. Extrema, maxima or minima or saddle points. The points are, first we calculate fx, fy. We partially differentiating the function with respect to x and with respect to y. We get fx and fy. The second point is fx is equal to 0 and fy equal to 0. Solving these two equations, we get critical points. Either we get 1 point or more than 1 point. That points are known as critical points. Then calculate fxx, second order partial derivative, fyy, then fxy. Calculate fxx. We partially differentiating fx with again with respect to x, partially differentiating fy again with respect to y, partially differentiate fx with respect to y. Then we get fxx, fyy, fxy. Then calculate the value of d. To calculate the d, we have a formula. Formula is fxx x naught y naught, fyy x naught y naught, fxy whole square x naught y naught. We substitute the critical points in this fxx, fyy, fxy whole square. Then we get different values of d. If d less than 0, critical point is a saddle point. Critical point is a saddle point. D greater than 0. When d greater than 0, two cases, fxx x naught y naught greater than 0, fx x naught y naught less than 0. D greater than 0 and fx x naught y naught greater than 0, our conclusion is relative minima. D greater than 0 and fx x naught y naught less than 0, our conclusion is relative maxima. In third case, d equal to 0, there will be no conclusion. This is the working rule or working procedure for locating extrema of a function z is equal to f of x. ഈ വർക്കിംഗ് റൂൾ കൃത്യമായിട്ട് നിങ്ങൾ പഠിച്ചു വെക്കുകയാണെങ്കിൽ നമുക്ക് ഇത് ഉപയോഗിച്ച് ഏതൊരു ഫംഗ്ഷൻ തന്നാലും ആ ഫംഗ്ഷന്റെ എക്സ്ട്രീമ എന്ന് പറയുമ്പോൾ മാക്സിമ ഓർ മിനിമ ഓർ സാഡിൽ പോയിന്റ് നമുക്ക് കറക്റ്റ് ആയിട്ട് ചെക്ക് ചെയ്യാൻ സാധിക്കും. ഓക്കെ, എല്ലാവരും കൃത്യമായിട്ട് എഴുതിയെടുക്കുക കേട്ടോ.